So this is a classified paper related to topic acid, base, and alkali. So we did the first 5 pages from this topic. So we will start with page 6. You can use screen annotation to answer these questions. You can also use the chat, starting with part A. This is what we did in the last part B now. Nitrate decompose when heated. When zinc hydrated zinc nitrate is heated, the oxygen gas is given off. Describe the test for oxygen. How we can test oxygen is present? What we should do? So we'll use a growing splint. No, lighted splint is for hydrogen. If you mention a lighted splint, it is acceptable in case of oxygen, but then the observation will be different. If you mention a lighted splint, then you will mention it bursts into flames. If you mention a lighted splint for oxygen, otherwise, better not to mention glowing splint. It will relight. Then we have to balance this equation for a decomposition of a zinc nitrate. So this 2 is there, so definitely 2 with zinc. Then for nitrogen, this 2 and multiplied with this 2, 4. Nitrogen is 4, not 2, because this 2 is multiplied with all of them. So it should be 4. Then try to balance hydrogen. But how many hydrogen are there? Look, ZnNO3 bracket 2 dot 6H2O. And then there is 2 as well here. So this 2 is multiplied with both of them. Because one molecule of a zinc nitrate contains 6 water molecules. So 2 will contain 12 water molecules. And how many hydrogen will be there? How many hydrogen will be there? So this is 6 multiplied by 2 makes 12, and 12 multiplied by 2 makes 24. So we need 24 hydrogen. That's why it should be 12 here. So for a hydrated compound, like example, if I write CuSO4.5H2O, it means one word copper sulfate need 5. But if it was 2, then how many hydrogen will be there? This 2 is multiplied with this as well and this both compounds. So we have 2 zinc, we have 4 nitrogen and oxygen. Then just check just to confirm whether 3 multiplied by 2, 6 multiplied by 2, 12 plus 6, 18. So it is 4 multiplied by 2, 8, 10, 12. So oxygen should also be balanced. So 2 with zinc, 4 with NO, and 12 with water molecule. So remember, if 2 is there, this 2 is multiplied with all of them. Some sulfates are hydrated. When hydrated sodium sulfate are heated, they give a water molecule. The student carries out an experiment to determine the value of X. Hydrated sodium sulfate crystals are weighed. The hydrated crystals are then heated and remaining solid weighed. How the student can check that all of the water is given off? So he will weight it again until it gives us the constant mass. Like student using a crucible, whenever determination a crucible is there, so we heat it, then we cool down, and then we measure the mass, and we repeat the procedure until we found that the mass is not changing. So reweigh until constant mass. Color change is not acceptable here. because this is a group 1 compound. Group 1 compound are white solid. You cannot mention a color change. It is not a copper sulfate, it is a sodium sulfate. Copper sulfate is colored, but sodium sulfate is not, it's a white solid, so you cannot mention the color changes also. They will not accept the color change. In an experiment, 1.61 grams of sodium sulfate was there. Calculate the moles remaining. It is heated until the mass of a sodium sulfate is 0.71. So we have 0.71 grams of sodium sulfate divided by its molar mass, which is 142. How many moles will be there? 5 exponent minus 3, or you can write 0.005. Then mass of a water molecule given of, so this was total mass of the hydrated and this is anhydrous, so you subtract 1.61 minus 0.71. This will give us the mass of the water which is given off, that is 0.61 minus 0.71, 1.61 minus 0.71, that is 0.9 grams, so 0.9 grams. Then number of moles of the water, moles equal mass in gram over molar mass. So molar mass of a water is given 18. So 0.9 divided by 18. What's the answer? So 0.05. Okay. Now we compare 0.05. Now we compare the moles of anhydrous, like this was sodium sulfate, and water molecules. When we compare, this was 0.005. This is 0.05. To take the simplest ratio, we divide by the smallest value. So 0.005 we divide. So this will be 1 and this will be 10. So the ratio between them is 1 is to 10. So how many water of crystallization should be there? It should have a 10 water of crystallization. Value of X should be 10. Is it clear, this question? These type of questions are common now, in which you have to work out the water of crystallization by using the ratio of the moles.